Hey everybody, welcome to your second to last unit before new material is done for the AP exam. And we had kind of discussed in class that sometimes it's going to be easier to look at a graph with horizontal rectangles instead of vertical rectangles in order to get the area between two curves. So let's go ahead and take a look at the function y equals x minus 1, and that's just going to be this line here. And this guy, now this is not a function, but this is a relation between y equals plus or minus the square root of 3 minus x. So the top part is y equals 3 minus x, rad of 3 minus x, and then the bottom part is the negative part of it. All right. If we integrate this problem in terms of y, instead of doing vertical rectangles, we can take the idea that we're adding up billions and billions of horizontal rectangles. And unlike before where we were adding them up from left to right, now we're going to add them up from top to bottom. And the width of each rectangle is infinitely small, but we call it dy. Okay? So as long as we change everything so it's in terms of y, and we can integrate using the right minus left idea. So let's go ahead and take a look at this function here. And our first step is to change everything so it's in terms of y. The graph here is pretty clear on where the y values are. Okay, this y value is at -2, and the top y value is at +1. Originally, we had a curve of y equals plus or minus the square root of 3 minus x. If we want to get this in terms of y, it means we have to get x isolated. So if we square both sides, we'll have y squared equals 3 minus x, and y squared minus 3 equals -x, which means that 3 minus y squared equals a +x. Okay, so that's the first curve. And the second function that we had was y equals x minus 1, so that just means that y plus 1 equals x. So now we have two functions that are in terms of y, and we can identify the right part of the shaded region, and it's not really shaded, so if it'll make you guys feel better, we can shade it, okay? Hold up. All right, now we got that. So we'll go ahead. All right, so there's the region that we're talking about. Suppose I should have done that in the first picture. See, I'm not perfect after all, you guys. I know, big shocker. All right, so let's go ahead and take a look at the right part of the shaded region is that curve right there. And that is defined by this. The left part of the shaded region is that function right there, which is defined by the y plus 1. So when you put all this together into an integral, the area of the shaded region is going to be bottom of the shaded region to the top of the shaded region. So we're doing y values now. Everything has to be y. And the right function is going to be, or I should say the right part of the curve, the right part of the shaded region, is going to be that 3 minus y squared, right minus left. And this is all in terms of dy. So now that the integral is set up, this is no different than any of the problems that we've been doing till now, just the variable is y instead. But you do it the exact same way on the calculator if I give you a calculator problem, and you do it the exact same way by hand if you do it by hand. So let's go ahead and do this problem by hand. We would simplify the integrand. Okay, so as far as our constant terms go, we've got 2. As far as our squared terms, we only have a y squared, and then our linear term, we've got the minus y, and this is all dy. So if you integrate this now, okay, some of you are doing the antiderivative and then you're still leaving the integral symbol, so make sure that once you do the antiderivative, that integral symbol becomes the evaluation symbol, which you'll see in a second. So the antiderivative of 2 is going to be 2y. The antiderivative of y squared is going to be y cubed over 3. And the antiderivative of y is going to be y squared over 2. And we are evaluating this from our bounds of -2 to +1. All right, so I'm going to go ahead and plug in my top bound, and I'm going to use red for this guy. So we're going to have 2 times 1 minus 1 cubed all over 3 minus 1 squared all over 2. And I'm just going to go ahead and simplify this a little bit. 2 minus a third minus a half. Okay, and I'm going to show the subtraction of the quantity of, we'll do the bottom bound in blue. Okay, so if you plug in your bottom bound, you're going to have 2 times a -2, so that's going to be -4. You're going to have minus a -2 cubed. -2 cubed is going to be -8, so this is going to be a +8 thirds. And then -2 squared is going to be a +4. 4 divided by 2 is +2, but then we've got -2 because of the negative sign. So if we distribute that negative, this is where most people mess something up. And hopefully I'm not messing it up right now because that's really awkward otherwise. -8 thirds, and this comes a +2. So I'm going to combine the 2, the 4, and the 2. And that gives us an 8. I'm going to combine the -1/3 with the -8 thirds, and lucky for us, that gives us -9 thirds, which we all know is 3. So that guy's gone, and that guy's gone. And the only thing left is the -1/2. So 8 minus 3 is 5. 5 minus a half is 4.5. So that's the area of the shaded region. Yay, ta-da! And take a look at, okay, so as is shown here, this is an on your own problem with the Calc OK. So I'm going to walk you through the steps, and you're going to bring your work to class, and we're all going to do the dance of joy. So the first thing I want you to do is graph this guy. And you will see that it's going to be beneficial to do this in terms of dy. Right? If you turn your head on its side, it's going to be very clear that doing horizontal rectangles is going to be a little bit easier than vertical. Second thing I want you to do is identify your bounds. Remember, that's where the guys intersect. Step number 3 is to write the integral. Remember, everything is in terms of y. So that means solve all those equations and get x alone. And P.S. before I forget, in order to graph this on your calculator, you can put into y1 the positive square root, and you can put into y2 the negative square root, and then into y3 you can put the x minus 2. Okay? Once you've got your integral and you get everything in terms of y, then go to the home screen or a calculator page, whatever you want to call it, and do the definite integral. Okay, from your low y value to your high y value, your right function or your right curve minus the left. This is all in terms of dy. Okay, do not attempt to graph the integral because it won't look like the functions or the graphs themselves. Okay, this integrand is an equation that is going to give you the area between two curves. It is not going to look like any of the functions, okay? So those are the steps. I know you can do this. Come to class with it ready, and we'll discuss the answers. Hope you guys have a good one. Bye.